Hello friends, welcome to Engineering Funda family. In this video, I will solve one comprehensive example based on cyclic code. After watching this example, you can solve each and every parameters of cyclic code. So let us solve this problem step by step. See here in question, we have been given with generator polynomial of systematic cyclic code 7, 4. Generator polynomial is x cube plus x plus 1. And based on this data, we need to identify generator matrix. We need to calculate code word for message 1011. We need to calculate parity check matrix. We need to identify decoding matrix. We need to identify syndrome if received data is 11011100, as well as we need to perform error correction for above received data. So first of all, we need to identify generator matrix. To understand generator matrix, you need to understand data which is given to us. See here, we have been given with 7, 4 code. What is the meaning of 7, 4? It means n, k. Here, small n is 7, means total bits with code word is 7 and k is equals to 4, means information bits are 4. Here we have generator polynomial. You can observe generator polynomial g of x that is given, that is x cube plus x plus 1. Using this generator polynomial and n, k code, one can understand generator matrix. Let me explain that. See, generator matrix, that is G, and generator matrix is a combination of identity matrix I of k and parity matrix. Now I'll explain you calculation of identity first. See, identity is I of k. So that will be k cross k matrix. And with identity, we will be having ones with diagonal. So with identity, diagonal will be having ones and other bits are zeros. So here I'm making identity matrix in which diagonal is having ones and other bits are zeros. So this is our identity matrix, right? Now we need to understand parity matrix. See, for parity matrix, here we need to calculate parity bits as per row calculation. So here I'll show you parity bits calculation as per row. Let me explain that. See, if you want to calculate first row of parity, then first row of parity, that will be remainder of x to the power n minus 1 divided by g of x. G of x is generator polynomial. So here, if you observe, n is 7, that is given. So here, x to the power n minus 1, that will be x to the power 6, divided by generator. Generator polynomial is x cube plus x plus 1. So here, we need to understand this remainder calculation. Similarly, for second row, calculation is same. Only difference is here, x to the power n minus 2 will be there. So for second row, what we need to do? For second row, here we need to perform x to the power n minus 2. So x to the power n minus 2 means x to the power 5. For third row, what we need to do? For third row, here we need to perform x to the power n minus 3. X to the power n minus 3 means x to the power 4 over here, right? And for fourth row, here we need to perform x to the power n minus 4. So here there should be x to the power n minus 4 means x to the power 3 over here. So these remainders that we need to calculate, and based on that we can make parity matrix over here. So first of all, what I'll do is I'll perform first division. See, in first division, here we have x to the power 6 divided by generator polynomial. So x to the power 6 divided by generator polynomial is x cube plus x plus 1. And always remember, see this division, that is modulo 2 division, right? See here power is x to the power 6. So with this we need to multiply x to the power 3. So here we will be having x to the power 6 plus x to the power 4 plus x to the power 3. If you multiply this with x to the power 3, right? See in modulo 2, see similar data that is getting cancelled. So this x to the power 6 and this x to the power 6 that is getting cancelled. So we'll be having x to the power 4 plus x to the power 3. Here highest power is x to the power 4. So with this we need to multiply x. So we'll be having x to the power 4 plus x square plus x. Now again, if you observe, this x to the power 4 and this x to the power 4 that is getting cancelled. And here we will be having x cube plus x square plus x. Now here highest power is x to the power 3. So with this we need to multiply 1. So here we will be having x cube plus x plus 1. Now over here also we need to eliminate similar data. See x cube is getting cancelled and x is getting cancelled. So here we will be having x square plus 1, right? So this x square plus 1 that we need to place over here. So this remainder is x square plus 1. Now let us identify this second row. So for second row, what we need to do? For second row, here we need to perform division of x to the power 5 divided by x cube plus x plus 1. So here highest order is x to the power 5. So with this we need to multiply x square. So here we will be having x to the power 5 plus x to the power 3 plus x to the power 2. If you multiply this with x square, again eliminate similar data. X to the power 5 is getting cancelled. We'll be having x cube plus x square. Here highest order is x to the power 3. So with this we need to multiply 1. So here we will be having x cube plus x plus 1. Again eliminate similar data. So x cube is getting cancelled and we'll be having x square plus x plus 1. Now see here order is x to the power 2, which is lower than this. So here we will be having remainder, that is this, and this remainder that we need to substitute with this second row. So here remainder is x square plus x plus 1. Now I'll identify remainder of this third row. So here we need to perform division as per x to the power 4 divided by x cube plus x plus 1. So here order is x to the power 4. So multiply this with x. So here we will be having x to the power 4 plus x square plus x. Now if you eliminate this, then you will be getting x square plus x. So this order is lower than this. So this will be our remainder. So let me note it over here, x square plus x. Now similarly we need to identify fourth row. See in fourth row, here we need to perform division of x cube divided by x cube plus x plus 1. Now here see order is same. So simply just place 1. So here we'll be having x cube plus x plus 1. This x cube is getting cancelled. We'll be having x plus 1. So this remainder, that is x plus 1, right? So this is how one can do modulo 2 division. Now based on this polynomial, we need to place parity bits. If you observe here we have 3 columns. So x square plus 1 means what? X square plus 1 means here we have 1, 0, 1. x to the power 2 is having 1, x to the power 1 is having 0, and x to the power 0 is having 1, right? See, here we have 3 elements, so it will be 1, 1, 1. Here we have x square and x, so we'll be having 1, 1, 0. Here we have x plus 1, so we'll be having 0, 1, 1. Now let us place this row wise. So we have 1, 0, 1, first row, second row, that is 1, 1, 1, third row, that is 1, 1, 0, and fourth row, that is 0, 1, 1. So that is how one can have generator matrix. See, this generator matrix, that is quite complex. After that, things are easy. Now we need to understand code word for message. So here we need to understand code word for message 1011. Let me explain that. So if you want to identify code word, then one should know code word C, that is a multiplication of message and generator matrix. Here, what is message? See, message is 1011. So message is 1011. And what is generator? See, generator that we have calculated. So this is generator matrix. So let me write this generator matrix. First of all, once we have this generator matrix and message, one can identify code word. Here, one thing that you need to understand, say this code word that we calculate for systematic cyclic code. So for systematic cyclic code, when you write any code word, at that time initially there will be message only. The reason is here we are performing multiplication of this message with this identity. So initial 4 bits, that will be message only. So this message, that will be initial 4 bits. If you multiply this with this identity, then that will be message only. Now for last 3 bits, we need to perform this row into this column. So fifth bit will be this row into this column. So here we have 1 into 1, so that is 1. Then 0 into 1, that is 0. 1 into 1, that is again 1. 1 into 0, so here we have 2 ones. So 1, 1, that will be 0. Similarly, for next bit, this row into this column. So 1 into 0, 0. 0 into 1, 0. 1 into 1, 1. 1 into 1, 1. So we have 2 ones, means here we have 0. Similarly, last bit, that will be this row into this column. So 1 into 1, 1. 0 into 1, 0. 1 into 0, 0. 1 into 1, 1. So here we have 1, 1. So this will be 0. So you can observe here we have code word, that is 10110000. Right. So that is our code word. Now, next question that we are dealing with to identify. See, in next question, here we need to calculate parity check matrix. Parity check matrix, that is quite simple. Let me explain that. See, when you talk about parity check matrix, then that is denoted by H. This parity check matrix, that will be P transpose and identity n minus k. This is what you need to understand. Parity check matrix, that will be P transpose and identity n minus k. See this parity matrix that we have calculated. You can observe parity matrix is this only, right? This is generator matrix. So parity matrix that we have, based on this parity matrix, here I can write P transpose. What is P transpose? In P transpose, this column that we need to convert in terms of rows. So this first column, that will be first row over here. This second column, that will be second row over here. And this third column, that will be third row over here. So that is how one can have P transpose. So here, first of all, I'll write down P transpose, that is this. Now I need to write down this identity. See, this identity is n minus k. If you observe, here we have n comma k code. N is 7 and k is 4. So n minus k, that will be 3, right? So here identity I3 that we need to write. One should know with identity, diagonal is having ones and other bits are zeros, right? So this is how one can write identity n minus k, and this is what P transpose, that will be parity check matrix, right? Now let me explain next parameter. See, here in next parameter we need to understand decoding matrix. This is quite interesting. Let me explain that. See, decoding matrix, that is based on parity check matrix only. See, decoding matrix, that one can understand based on H transpose. So here, what is H transpose? This is H matrix. So with H transpose, we need to convert rows into column. So this first row, now that will be first column. So we have first column, that is 111 0 1 0 0. This second row, now that will be second column, that is 0 111 0 1 0. And this third row, now that will be third column. So 111 0 1 0 0 1, that is our third column. So that is how one can have decoding matrix. Now how it will be decoding data? See, this decoding matrix that explains in which bit we have error. Like if you have syndrome, that is first row, then one can say we have error in first bit. So this first row that explains first bit error. This second row that explains second bit error. Likewise, here we have seventh row. So this seventh row that explains seventh bit error. And if you have 0 0 0, if you have 0 0 0, then one can say no error is there. So here we need to understand syndrome. If you have syndrome, that is first row, which is 1 0 1, then one can say first bit error is there. If you have syndrome, that is 0 0 0, then one can say there is no error in received data, right? So now what I'll do is I'll calculate next parameter. See, in next parameter, we need to understand syndrome if received data is 1 1 0 1 1 0 0. So now I'll explain you syndrome calculation. First of all, let me explain what is syndrome. See, syndrome is denoted by S, right? And if you want to calculate syndrome, then that will be remainder of received data y of x divided by generator g of x. So first of all, you need to understand what is received data y of x. Here, data is given in terms of bits. You can observe. Received data is 1 1 0 1 1 0 0. So let me note it down. See, received data that is given here, that is 1 1 0 1 1 0 0. That is the received data. Now from this received data, if you want to write down y of x, then here one should know, see, with this first bit, we have x to the power 6, second bit is having x to the power 5, then x to the power 4, x to the power 3, x to the power 2, x to the power 1, and x to the power 0 is there with us, right? So here if you observe, with x to the power 6 we have 1, then x to the power 5 that is having 1, then x to the power 3 that is having 1, then x to the power 2 that is having 1. That is how we have y of x. G of x that is given in question. You can observe in question g of x is given, that is x cube plus x plus 1. So let me note it over here. See, g of x that is given, that is x cube plus x plus 1, that is given in question, right? Now, here we need to identify remainder of this division. So here y of x, that is there with us. What is y of x? Y of x, that is x raised to 6 plus x raised to 5 plus x raised to 3 plus x raised to 2. And what is g of x? That is x raised to 3 plus x plus 1. So this remainder that we need to calculate. So again, we need to perform modulo 2 division. Let me explain this. See here, now I'll calculate this modulo 2 division. So here we have x raised to 6 plus x raised to 5 plus x raised to 3 plus x raised to 2. And here in division we have x raised to 3 plus x plus 1. If you observe, here highest power is x to the power 6. So with this, we need to multiply x to the power 3. So here we will be having x to the power 6 plus x to the power 4 plus x to the power 3. If you multiply x cube with this, right? Now, simply we need to eliminate similar data. So x to the power 6 is getting cancelled. X to the power 3, that is also getting cancelled. You can observe. So now we'll be having x to the power 5, x to the power 4 and x square, right? Now highest order is x to the power 5. So with this we need to multiply x square. So here we will be having x to the power 5 plus x to the power 3 plus x to the power 2. So here again we need to eliminate similar data. X to the power 5 is getting cancelled, x square is getting cancelled. So we'll be having x to the power 4 plus x to the power 3. Now here highest order is x to the power 4. So with x cube we need to multiply x. So here we'll be having x to the power 4 plus x to the power 2 plus x. Now again eliminate similar data. So here we have x to the power 3 plus x square plus x. Now highest order is x to the power 3. So you can multiply 1 over here. So we'll be having x cube plus x plus 1. Now again eliminate similar data. X cube is getting cancelled. X is getting cancelled. So we'll be having x square plus 1. So x square plus 1, that is there with us. So this remainder, that is x square plus 1. So what is the meaning of x square plus 1? See, digitally, here if you talk about syndrome, so that is having 3 bits. So x square plus 1 means 101. X square plus 1 means 101. So you can observe 101, that is there with this first row. So one can say here, as per decoding matrix, first bit error is there. So with this received data, we have first bit error as per syndrome S, right? So here we have first bit error. Here received data is having first bit error. So first bit will be 1 and remaining 6 bits, that will be 0, right? If you talk about received data, then what is received data? That is 11101100. And here in last question, if you observe, we need to correct the error for received data. So error correction, that is quite simple. See here, correction that is done as per E XOR Y. So if you perform XOR operation, then 1 1, that will be 0, 0 1 1, 0 0 0, 0 1 1, 0 1 1, 0 0 0, 0 0 0. So here we have performed error correction with first bit, right? So that is how one can perform error correction even. So in this video, what I have done, I have explained you error correction along with error syndrome, as well as I have explained you how one can generate code word, right? And based on generator matrix, one can understand parity matrix. From parity matrix, one can understand parity check matrix. From parity check matrix, one can understand decoding matrix. From decoding matrix, one can understand error correction even as per error syndrome. And error syndrome, that is remainder of received data divided by generator polynomial. So these are the things that you should keep in your mind. I hope now you are having fair enough idea about what is cyclic code, how encoder is performing, and how decoder is performing, and how one can have error correction. Still, if you have any confusion, just place that in comment section. I'll be happy to help you. Thank you so much for watching this video.